Lucy's shopping for a sports utility vehicle. The dealer says that he has 3 different models and that each model is available in 5 different colors. So complete the tree diagram to determine how many different choices Lucy has. So when you do a tree diagram, you guys, you have to do it title on the top and the options downwards. What I find is people want to do trees like a tree looks like. So you want to go this way. That's not how we do tree diagrams. So our first highlight, our first underline here is going to be a model. So we have the Cross 4, we have the X-Ground, and we have the Trail Pro. So if they just, the only option was model, we'd have 3 different options and we'd be done. Okay? But what they said is each model actually has 5 different color choices. So off of the Cross 4, you'd go blue and then red, then silver, then white, and then black. So with the Cross 4, I actually have 5 different options, right? With the X-Ground, I have 5 different options as well. And then with the Trail Pro, I have blue, red, silver, white, and black. So I would have the Trail Pro in blue, Trail Pro in red, Trail Pro in silver, Trail Pro in white, and then Trail Pro in black. So if each of those options has 5 options, how many total options do I have of vehicles? How many choices does Lucy have? 15. Because we could just actually count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But there has to be a better way. Because what if I said there was 20 models of car, each model of car had 10 different choices, then you'd have to do 20, and off of each of the 20, you'd have to do 10 little lines. There's got to be a better way, right? That is not the quickest method. So look at the number of choices there are for the model and the number of choices that there are for the color. How do we use these numbers to arrive at the 15? What could we do? There's 3 models, there's 5 colors. Yeah. So there's 3 times 5, so there's 15 options. So this is part of the fundamental counting principle. The fundamental counting principle says if there's different parts that make up a whole object, you can multiply them. So if I said maybe even forming an outfit for the day, right? And you went into your closet and you said, okay, in my closet I have 20 shirts, I have 7 pairs of pants, and then at the door I have 2 options of footwear. Okay? So 20 and then 7 and then 2. Well, if I took the 20 options and I made myself a little tree diagram, it would take me forever, right? But what I could do is I could just go 20 times the 7 pairs of pants times the 2 options of shoes and give you how many total different types of outfits I could have, right? So what the fundamental counting principle states is if you have parts, different parts that make up a whole, what you can do is you can take this part and times it by the options of this part and times by the options of this part and get you the total. Okay? So the dealer then tells Lucy that each of the sports utility vehicles comes in 2 editions, standard edition and leather edition. So what we'd have to do then is we'd actually have to go off of here and we'd have to go standard and leather, standard, standard, and we'd have to go 2 more options off of it, right? Off of every single one. So instead of doing that, what could I do? I could do the 3 models times the 5 colors times the 2 editions. So I'd actually end up with 30 options. Then flip over. So the fundamental counting principle, the answer to C part 2 on the previous page is determined by multiplying the number of models 3, by the number of colors 5, by the number of additions 2. This is an example of what's called the fundamental counting principle. Consider a task made up of several stages. The fundamental counting principle states that if the number of choices for the first stage is A, the number of choice for the second stage is B, the number of choice for the third stage is C, etc., then the number of ways to complete that task is A times B times C times however many more there are. So the next one we're going to look at a toy manufacturer makes a wooden toy in 3 parts. You need all 3 parts of the toy to make the full toy, right? You can't just have like 2 pieces and make the toy. So we have 3 parts that make up the whole toy. So we're going to be able to use the fundamental counting principle. But first we're going to display it in a tree diagram. So part 1, the top part may be colored red or blue. So I'm going to label this as top. Because I remember I always put my label along the top and then I put my options down. And you're going to have trees actually going out sideways. So my options for part 1 are red or blue. Part 2, the middle part can be orange, white, or black. So we're going to put the middle. It can be orange, white, or black. So I'm going to go orange, white, black. Orange, white, black. Then part 3, the bottom part can be yellow or green. So this is the bottom. So off of each of these options, I have 2 options, right, for the bottom, yellow or green. So my option for toys here would be the top being red, then the middle being orange, then the bottom being yellow. Or the top being red, the middle being orange, and the bottom being green. Or the top being red, the middle being white, the bottom being yellow. Red, white, or green. Red, black, or yellow. Red, black, or green. And all those different options, right? So how many options do I have? Nope. How many options do I have? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 different toys. So how could we do it doing the fundamental counting principle? Well, we could have 3 blanks. This would be the top. This would be all the options for the middle. These would be all the options for the bottom. So Braden, how many options do I have for the top? 2. Mira, how many options do I have for the middle? And Will, how many options do I have for the bottom? 2. Now, there's a key thing here between and or. If you use the word and, it means multiply. So I'm going to leave a little note here. And I multiply. If I use the word or, I add. This comes later, but I just want to do it now. Anyways. So if I need the top and the middle and the bottom to make the toy, I multiply. If I need the top or the middle or the bottom to make the toy, then I add. Do I need and or or? Can I have the top or the middle or the bottom and still have the whole toy? No. I need the top and the middle and the bottom. So that's why I multiply them. 2 times 3 times 2 is 12 different toys. So here is a little repeat part here, but I find that if you don't write it out yourself up here that no one reads this. But it says here, in the previous example, the toy consisted of part 1 and a part 2 and a part 3. The total number of possible toys was found by multiplication. In examples involving and, the number of arrangements will be found by multiplying. So if you use the word and, you multiply. So class example 2. A math quiz consists of 6 multiple choice questions. Each question has 4 choices, A, B, C, or D. Use the fundamental counting principle to determine how many different sets of answers are possible. So people will say to me, well, there's 6 multiple choice questions, 4 options. That doesn't leave me very many different answer keys. So I should be able to just guess the answers correct. Actually, it leaves you a lot of different choices for answer keys. So we have 6 different questions. So for each question makes up a part of the test, right? So I'm going to do 6 blanks. 1, 2, 3, 4, 5, 6. This is number 1, number 2, number 3, number 4, number 5, number 6. So we have 6 questions that makes up that test, right? Now, what you always do is you put the number of options above, not the actual option, but the number of options above. So I have the options of A, B, C, or D. So I always list my options below and then put how many there are above. So A, B, C, or D gives me 4 options. So I'm going to have 4 options above. Then how many for the rest? 4, it doesn't change, right? Sometimes they specify and they'll say the first answer to the first question is A, and then after that it can be options A to D, and then I would only have 1 option for the first one if that was the case. So each of these have 4 options. Now some people will tell me that's 4 times 6. That's not 4 times 6. That's 4 options multiplied. Now why did I multiply them and not add them? Because you have to do the entire task. I need this question and this question and this one and this one and this one and this one to do the test. If I used plus signs, you would be telling me I can have this question or this question or this question or this question, so you could pick which ones you want to do, which isn't true. That's why it's multiplying the and. So this is actually 4 to the exponent 6, because you have 4 6 times. Not 4 times 6. Now, if you don't know where that is in your calculator, you can go 4 and the little symbol below the clear button. That's exponent 6. It's below the clear button. So actually, there's 4,096 different options of answer keys for this test. And if you start trying to list all the different ways, you're going to see, yeah, there is lots of options. The first answer could be A, right? Then A, B, 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 B. Then A, C, 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 C. Then A, D, 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 and then B, A, right? Like there's lots of different options you could have for answer keys. So you think, oh, a 6-question test, I could guess my answers correctly. There's actually 4,096 different answer keys I can make with a 6-question quiz with 4 different answers. So you'd have a 1 in 4,096 chance of guessing the correct answers if you were just randomly guessing. So that's why we don't want everyone going to a test guessing. All right. So when solving problems involving restrictions, it's important that you deal with the restrictions first. So for example, like I said on the last one, on the 6-question quiz, if the first answer had to be an A, I would deal with that blank first, and then the rest of the blanks after that. It doesn't matter the order. They have to deal with the restrictions first. All right? So, A. Eric has been assigned the task of determining how many odd 4-digit numbers there are. How can you tell something's odd? A number's odd. Is 13 odd? Is 14 odd? Is 15 odd? Can't be divided in half. Yep. Is 16 odd? No. Is 17 odd? Yes. Is 18 odd? No. What's the only number I'm changing? The back number, the last digit. All of them were ones before that. It was like 16 is 1 6, 17 is 1 7. But you guys were telling me they were odd based on the fact that I told you the number. But the only thing I was changing was the last digit, right? So in order to tell if something's odd or even, it's just that last digit. If the last digit is odd, it's odd. If the last digit is even, it's even. because the other digit didn't matter, right, when I was asking you. I can go like 1,743,000. Odd or even? Odd, because it just depends on the 3. Okay? So we have a 4-digit number. Okay? The other thing is, if it's a 4-digit number, you have to have 4 blanks. Now, is 1,000 a 4-digit number? 1000. Yes. Is 0267 a 4-digit number? No, it's a 3-digit number with a 0 in front. Right? That's all it is. So whenever it says 4-digit number or 3-digit number or 10-digit number, that is telling you that the first digit can't be 0. Okay? You need to know that it's not going to say a 4-digit number and the first digit can't be 0. You need to know that it can't be 0. Okay? And odd, this meant that the back number, which is also known as the last digit, has to be odd. So there's 2 restrictions on this 4-digit number. The first number can't be 0 because they told me it's a 4-digit number, and the back last number has to be odd. Okay? He has been told that the number such as 5,267 is a 4-digit number, whereas 0267 is a 3-digit number. They won't tell you that. They're not that nice. Okay? They'll just say 4-digit number, and you have to remember that the first digit can't be 0. So we're going to go through the first step of his work as shown. Explain his reasoning. Why is there 5 options for that back number? Remember, the number that's above the blanks is the number of options. What you list below are the options. So the only options we have for these blanks are the numbers 0 to 9. Why can't I put a 10 in the blank? 10 is a 2-digit number. Every single one of these blanks can only hold a 1-digit number. So I have the options of 0 to 9. Why is there only 5 options on this black one, on the back one? There's only 5 number options. So I always list my options below and list how many of them there are above. So I have the option of this could be a 1, or it could be a 3, or it could be a 5, or it could be a 7, or it could be a 9. It can't be a 0 because then it would be even. It can't be a 2 because then it would be even. It can't be a 4, it would be even. 6, it would be even. 8, it would be even. 10 is a 2-digit number. I'm out. Okay? So I will list the options below and then say how many of them there are up here. This doesn't mean that this is the number 5 is the last number. In high school, I always screwed that up, and I always think, well, that's the actual number that's left there. This isn't the number that's left there. This is how many options there are. 1, 3, 5, 7, 9. I have 5 options for that last blank. Okay? Then I have to deal with my first blank, because that's my other restriction. The first blank can't be a 0, so it can be the numbers 1 to 9, right? So that's why they have a 9 here. This is the numbers 1 to 9. I never write it out separately like these blanks do in this book. I always just go like this. Okay, 4-digit number, I need my 4 blanks. All right? My back number has the options 1, 3, 5, 7, or 9. So that was 5 options. So I put the 5 options above. My first blank can't have a 0, so I'm going to cross off a 0. But I can have the numbers 1 to 9. The numbers 1 to 9 are 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 options for the first blank, correct? Was there any restrictions on the 2 middle blanks? No. So they can be the numbers what? There's 10 options because they're the numbers 0 to 9. 0 to 9 is actually 10 options, not 9. And then here I'd have 0 to 9 again. If I take out repetition, this is totally wrong. If I say you can't repeat numbers, this would be wrong. Because I'm allowing repetition, right? I could technically have 1, 1, 1, 1. So, whole different ballgame when we take out repetition, which would be the next one. So, do I need this digit and this digit and this digit and this digit to make the number? Or this digit or this digit or this digit or this digit? It's and, so I need to multiply. So below I list the options, above I list how many there are. So there's 4,500 4-digit odd numbers, in the world. Okay? You can break it down into pieces like this, but I like just listing them all together, not overthinking it. B. Eric has now been assigned the task of determining how many odd 4-digit numbers there are. So same question as before. However, no repeating digits. Okay? I'll show you how I deal with no repeating digits. So follow along. We still need to deal with the fact that there are restrictions, and we still have to deal with the restrictions first. Okay? So we have our 4 blanks. I'm going to deal with the odd first. So I have 1, 3, 5, 7, or 9. So I have 5 options. The moment it says that I can't repeat, I pretend to keep a number there. Okay? So which number do I want to pretend to keep there? 1, 3, 5, 7, or 9? Pick one. 9? Would I be wrong if I picked 7 or 5 or 3 or 1? No. Just pick one and circle it. The moment that there's no repeating, I circle that number and pretend it's now stuck there. Okay? So I have to go do my first blank next because it's a restriction. The restriction is it can't be a 0. It can't be a 0, but it also now can't be what? 9, because I kept 9 there, right? Whereas it was fair game over here because I could repeat. I can't repeat anymore. So now I have the options 2 to 8 and 1. I don't know why I didn't put 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. That's 8 options. I don't care if you count them out on your fingers. That is not nearly as embarrassing as getting the question wrong because you think 1 to 8 is 9 options or 7 options or something way more weird than that. That is embarrassing. Embarrassing counting on your fingers is not embarrassing. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Count it out so you do not mess up the options. So that's 8 options. Now, once again, no repeating options, right? So I have to pretend to keep one there. I'm going to pretend to keep the 1 because I feel like it. I wrote it off to the side by accident. Okay? I'm pretending to keep the 1 there. So now what options do I have for the middle? And this is where people get the question wrong. 2 to 8 are still available, right? I didn't use any of those. So 2 to 8 still available. And everyone puts that here. And then they say 7 options. But what haven't I used? 0. I haven't used 0. 0 wasn't an odd number, so I didn't use it. I couldn't use 0 here because I wasn't allowed to. Then it would be a 3-digit number. So you have to remember to bring the 0 back. Everyone forgets to do that. Do you see how that's an easy error to do? Forget to bring that 0 back? I do. So there's actually 8 options here, not 7. So I'm going to go 2 to 8 here. Keep the 0, and now I have 7 options. Now, do I need this number and this number and this number and this number to make the 4-digit number? Yeah. So what's 8 times 8 times 7 times 5? Put your hand up if you have it. 8 times 8 times 7. Cody? 60? 2160? I just did 21,000. Like that? Okay. Now, we went from 4,500 to that. Why? It's wrong. What is it? Oh, so close. Okay, we went from 4,500 to that. Why? Yeah. Because you can't repeat the digits, which causes you to take out anything where there's a repeated digit. So like 1, 1, 1, 1, out. 1, 1, 2, 3, out. 1, 1, 1, 3, out. Right? So you're kicking out a whole bunch of options. Okay. Before we do this question, how many letters are in the alphabet? 26 letters. Okay. Good. If you have to sing it in your head, go for it. Okay. How many, and this I did not know till last semester is actually true. How many, what is a vowel? People some don't. Yes. There's no sometimes Y in math, okay? A, E, I, O, U. And often on the diploma, if they do it, they'll say sometimes Y doesn't count. They usually say that. just so that you can't fight them on it. Because A, E, I, O, and U. So I didn't think I had to explain that before we do. So there's 5 vowels. This is the thing that people get messed up. They read consonants and they read it as constants, and they're like, what's a constant? And then I say it says consonant, and then they're like, what's a consonant? A consonant is not a vowel. So if there are 5 vowels and there's 26 letters in the alphabet, how many consonants are there? 21. You just subtract people. Consonants. Okay. Yeah. Yeah. Okay. So that is important. All right. So car number plates in an African country consists of a letter other than I or O. So it's a letter other than I or O. So I'm going to go I, O, and I'm going to put slashes through them rather than writing out the rest. So a letter other than I or O. So that's a restriction. I'm going to have to deal with that one. Followed by 3 digits. Followed by 3 digits. The first can't be 0. So 0 is out. Followed by any 2 letters which are not repeated. Now this should be actually written better, this question. It should say that the 2 letters which cannot be repeated, those 2 can only not be repeated. It's not actually dependent whatsoever on the I or O letter at the very beginning. Just these 2 letters can't repeat. So if this is A, this can't be an A. I don't care what this one is. All right? So these ones just can't repeat. So we need to deal with the restrictions first. So those 2 middle blanks that have no restrictions below them, those will be the things we deal with last. Does it say on here that the numbers can't repeat? No. So it only has to say that it can't repeat. If it doesn't say that it can't repeat, you assume that you can. All right? So I or O are out. So how many letters are options for this one? 24. There's 26 letters, subtract 2. Okay? This one, it can't be a 0. So I have the options 1 to 9. How many options is that? 9. Then I'm going to go back here to these ones because they actually have restrictions, and I'm going to leave those middle ones for last. So I have the options A to Z for this one. So I have 26. Then say I keep the Z because I can't repeat. I have A to Y. Remember, the moment you can't repeat, always circle an option and keep it. So now I have 25. No restrictions on these middle ones. So it's 0 to 9, 0 to 9. And I'm going to multiply them because I need them all in order to get it. So in this country, there would be 14,040,000 different car number plates. For the next 15 minutes, you're going to work on the questions 1 to 7 in the book, and then we're going to come back. So 15 minutes, work on numbers 1 to 7, following right. Example 5. There are 2 routes from Pitland to Queensland, 3 routes from Queensland to St. Luke's, 3 routes from Pitland to Rutherford, and 1 route from Rutherford to St. Luke's. How many routes are there from Pitland to St. Luke's passing through Queensville? So we could physically count these. We could go, okay, I go this route, then this one. So that's 1, 2, 3, 4, 5, 6. We could count it that way. Or we can use the fundamental counting principle. There's the piece from P to Q that I have to go through, and the piece from Q to S that I have to go through in order to get from P to S, correct? I can't just do part way. I have to use both routes. How many options do I have for this one? 2. How many options do I have for this one? 3. I have to take these options and these options to get from P to S. So that's 6 options. Or I could count them like I did and know that there's 6 options. All right? The bottom ones, I have 3 options to get me from P to R and 1 option from R to S. When I multiply them, I get 3. Now I have to decide, do I add the 6 and 3 or do I multiply the 6 and 3? Well, how do I decide between adding and multiplying? Or and. So, do I take these paths and these paths to get me to S? Or do I take these paths or these paths to take me to P to S? Is it or? Or, right? And would mean I have to take every single one of the options to get me there, which is not true. So it's or. If it's or, I add. Always think and add, which are 3-letter A words, do not go together. Okay, and add do not go together. It's and multiply or and add. And add, no way. Yeah. So there's 9. 9 options. Because there's 6 here, 3 here. In part C, we could travel from P to S via Q or P to S via R. The total number of routes was found by adding the answers from A to B and B. In any example involving or, the total number of arrangements will be found by adding or and add together. Class example 6. The telephone numbers allocated to subscribers in a rural area consists of one of the following. The digits 3, 4, 5, followed by any 3 further digits. So that's 6 digits total, right? So the option for the first blank is a 3. The option for the next blank is 4. The option for the next blank is 5, followed by any 3 further digits. Or, which means I'm going to add them. And when I have cases, this case or this case, I always add cases. Or the digit 2 followed by one of the digits 1 to 5, followed by any 3 further digits. Now, yes, I know this doesn't follow telephone numbers, which are actually a 7-digit number. I get that, but they can make up anything they want, okay? So, does it say anything about not being able to repeat numbers? No. So then we assume we can. The only time we can't repeat is if it says you can't repeat, or if it's a word, which is what we're going to deal with next, and I'll explain why. So, we deal with our restrictions first. This has to be a 3. How many options? 1. So I put the number of options above. This has to be a 4. How many options? This has to be a 5. How many options? What about these last ones? What can they be? 10, because they can be options 0 to 9, because we're allowed to repeat. And then I need all of these to make the number, so that's 1,000 options. Plus, the next set I have a 2, so I have 1 option. Then I have the numbers 1 to 5, so I have 5 options. And then 0 to 9. So 5,000. And 1,000 plus 5,000, I have 6,000 different options of phone numbers. The next one is the word English, okay? When you're looking at a word, you have that many letters that consist in that word. So for English, I have an E, I have 1 E, 1 N, 1 G, 1 L, 1 I, 1 S, 1 H. That is it. So even though it doesn't say you can't repeat, there's none of them that are repeating. So ultimately, I have 1 E to use, 1 N, 1 G, 1 L, 1 I, 1 S, 1 H. So the word can't be E. Okay? Also, the words don't actually have to be real words. You don't need to pull out like your dictionary and see if the word exists. Okay? That doesn't matter. But you are only allowed the amount of letters you have. So if I use the word pool, I would be allowed a P, 2 O's, and an L. Okay? So I could repeat the O's. But with English, I have nothing that repeats. Okay? We need to read thoroughly the question. because most people will assume we're going to use all the letters, but we have to, sometimes we use all the letters, sometimes we only use some of them. So let's read this. Consider the number of distinguishable 4-letter arrangements. So we're making 4-letter arrangements, which means we're going to have 4 blanks. We're not using all of the letters in the word. Okay? You have to read. Sometimes you use all the letters, sometimes you use some of them. That can be formed from the word English. Note there's an implication that each of the letters in the word English only occur once and cannot be repeated. Determine the number of distinguishable means different, 4-letter arrangements that can be formed from the word English. Okay? Anytime you rearrange a word, it's a permutation. Permutations, order matters. So, a license plate. If my license plate is BBF 906, is that the same as a license plate that's FBB 906? No, they're different license plates. So if the way you put the things down, the order matters, it's a permutation. So codes for your PIN for your cards. Does the order matter in which you put that PIN in? Like if my code is 1234 and I put in 4321, am I getting into my account? No. So it's a permutation. The order matters. Telephone numbers are permutations. The order matters. Words are permutations. The order matters. Words are always permutations. Think about your name. My name's Crystal. If I spelt differently, it is not Crystal. Okay? So the order in which you have your letters matters. So it's a permutation. And you're going to be given questions on your test and often on the diploma where you have to decide if even just the questions themselves are permutations or combinations. They don't even make you solve them. You just have to decide, does the order matter or not? Okay? So, any letter can be in any position. So, it's a 4-blank deal because we're looking at 4-letter words. Now, a lot of people tell me, well, it's English. 1, 2, 3, 4, 5, 6, 7. 7 letters. So, it's 7, 7, 7, 7. That would mean that the word E exists out of the word English. If I had pretend this is it Scrabble that has what is the one that has letter tiles? Is it Scrabble? Okay. Pretend this is Scrabble and I have English in letter tiles, right? Can I spell with English the word, those letter tiles sitting in front of me, those 7 letters, can I spell the word E? No, I have E and then I'm like, dang it, I'm done. I can't spell that word. Okay? So you don't have the option 7, 7, 7, 7. You have all the letters for English here. So that's 7, but I'm going to leave one there. So I'm going to leave the E there, let's say. How many letters do I have options for this now? 6. Say I leave the H this time. How many letter options do I have for this one? 5, and now I'm going to leave the I. And then 4, and say I leave the N. So what's 7 times 6 times 5 times 4? 7 times 6 times 5 times 4. Anyone have it? Is that true? Do you agree? Okay. The first letter must be an E. I have a restriction. The first letter must be an E, so I'm going to have to deal with that first. I still have 4 letters. The first letter, however, has to be an E. How many E options do I have? 1. I kept it there. Remember, with words, there's always just the number of letters you have. So how many options do I have for the next blank? 6. Then I leave one there. 5, leave one there. 4. It's like you're playing Scrabble, right? You've put down a letter, you have 6 little blanks left. You put down another one, you have 5 little blocks left. Yeah. So what's 1 times 6 times 5 times 4? 120? So I can make 120 different words starting with an E from the word English. First and last letter must be vowels. So English, E, N, G, L, I, S, H, has 5 consonants and 2 vowels. The first and last letters must be a vowel. So you can start with working on the first one or the last one. It doesn't matter which one, but you have to deal with those ones first because they're restricted. So the first letter must be a vowel. So I have the options of E or I. How many options is that? 2. But now I'm going to leave one of them there because I can't take both of them with me. If I take both of them and put them at the back, then now I actually only have 3 letters. I didn't leave a letter here at all, right? So I'm going to leave the I. So now I would only have the option of E at the back, which is 1. And I leave that there. Now I've used up the E and I've used up the I. So these middle blanks, I'd have N, G, L, S, H. So I have 5 options. Pretend I keep the L. Then I'd have N, G, S, H. 4. Multiply them and I get 40. So I have 40 different words that I can make, 4-letter words that I can make from the word English that start and end with a vowel. The last one is a little bit trickier. It's the word must contain a G. So I'm going to have cases. I'm going to have a case where I'm going to make the first letter be G. Or I'm going to have a case where I'm going to make the second letter be G. Or I'm going to have a case where I let the third letter be G. Or I'm going to have a case where I let the fourth letter be G. For each of these cases, you're doing a totally different, each of the cases you get to start over with the English letters, okay? So I'm going to start off with my restricted part. I have a G here. I have 1 option. Then how many letters do I have left for this? 6. Then I leave 1. 5. Then I leave 1. 4. So I actually have 120 options with G beginning with G. Then this one I'm going to start with the G, so I have 1 option. How many letters do I have left here? 6. Then 5. Then 4. So I have 120 again. Then I have 1 for this one. 6, then 5, then 4. So I have 120 again. And then I have 1 option. 6, then 5, then 4. So I have 120. So I can add them up. Or what could I do? Instead of doing 120 plus 120 plus 120 plus 120. 120 times 4. Because technically, this case is the same as answer is going to be same answer is going to be the same answer as that case, right? So if I take 1 case and I times it by all 4 cases, I'm left with 480. So I have 480 words, 4-letter words, that contain a G from the word English. Okay? So I want you to do numbers 8 to 17. I'll do for tomorrow, and will be checked while you do your quiz. 8 to 17.